Hello, 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 ladies and gentlemen. Root Beer here, and thank you for joining me as we take a look at question number 10 on our 2009 Cayley. The front of a rectangular prism has an area of 12 centimeters squared. The side has an area of 6 centimeters squared, and the top has an area of 8 centimeters squared. The volume of the prism in centimeters cubed is... Okay, how do I find volume for a prism? Well, I just need to know the length, width, and height. Now, I don't know the length, width, and height. They didn't give me that. They did give me surface areas. Okay, so what I'm going to do is I'm going to label my dimensions A, B, C. You could go L, W, H for length, width, height. You could go X, Y, Z if you're a coordinate person. That's fine. But it's a rectangular prism, so we're going to be able to repeat all these lengths. They all are the same. Okay. And so if we were to, say, focus on the front here, which is 12 centimeters, I know that that's A times B. Okay? Or if we focus on the side, which we know is 6, by my picture, it's going to be length A times length C. And up here on the top, which we'll make purple, we know that that was 8, so that's B times C. So I'm setting up all these equations. Now, I could solve for A, B, and C individually, and that's fine. And if you want to, you can absolutely do that. Let's see if I can just really quickly in my head. B should be 4, C should be 2, and A should be 3. Okay, and you can do that in your head if you're good at mental arithmetic. Excuse me. If you need to, you could instead say something like, well, B is 12 over A, and C is 6 over A, and then I know 8 is B times C, but then that's 12 over A, 6 over A, and so 8, I don't know what kind of symbol that is, 8A squared is 12 times 6, 72, and you can figure out A is going to be 3 from there. That's fine. If you want to do that, you go ahead. But here's a sort of a slick way, and I do like trying to show off the slick ways, especially because they can save time quite often. I mean, at the very worst, they're just as good as the computation method. But it more gets you thinking about how you solve more complex systems. Usually when you're doing a Waterloo contest, your eye is on the eventual goal of the Euclid. The Euclid is the big written question contest, or sorry, written solution contest. And it's more challenging. It's grade 12 level. But they also have, these just more advanced techniques. And you only get 2.5 hours on it, and so there's that time factor. And if you know the slick methods, you can save time, or sometimes you just can't do it with computation. There isn't enough information to actually figure out A, B, and C. So if we were in a sort of a situation where we just couldn't think of a way to get A, B, and C, maybe we don't have to. Remember, what's the volume? And that's what they're asking us for. The question does not care. It's multiple choice. They don't care how I get the answer. They're not interested in A, B, and C. They just want the volume. They want A times B times C. So what we have here is sort of what we might call a very symmetric-looking set of equations. A only appears twice, B only appears twice, C only appears twice, and it's the same sort of thing happening on the right side. They're all being multiplied. So what I might do is multiply all these together. Now 12 times 6 is 72, times 8 is, off the top of my head, I don't want to reach for my calculator, but I think I might have to. 72 times 8 is going to be 576. Right, because 72 is 9 times 8, and so we'll have 9 times 8 times 8, so that'll be 9 times 64, which is 3 squared times 8 squared, which becomes 3 times 8 all squared, 24 squared, and I have that one memorized. So I didn't have to reach for my calculator. Yay me. But of course, if you needed to, go ahead. But what happens when we multiply the 3 expressions on the right side? Well, I get 2 A's, 2 B's, and 2 C's. This is otherwise known as ABC all squared. Remember, squares can pop out. If you have AB to the power X, that's the same as A to the X, B to the X. Okay, it's a nice little law from exponents that hopefully you're familiar with at this point. But what do I want? I want A times B times C. I don't care what A actually is, that it's 3. Okay, so if I square root both sides, I'll get 24 is ABC, which is exactly what I was looking for. Okay, and 24, that's right there, it's A. That's the volume, 24 centimeters cubed. Of course, there's nothing wrong with doing the computation, getting A is 3, B is 4, and C is 2, either in your head or, process of elimination as I started doing. And that's fine too. And then 2 times 4 is 8, times 3 is 24. So it does all work out. But you can notice that the way I actually chose to write it up, a lot slicker, a lot neater, and it avoids the pesky complications and pesky computations of figuring out A, B, and C individually. Didn't need it. Okay? So that's question 10. Up next will be question number 11, the very first question in part B. So feel free to join me for that in the next video.